So our goal was to expand using our property from 2 days ago. We're using those same properties on yesterday's lesson. And number 1, did you expand it using addition or subtraction? Addition, right? Because it's a multiplication that's going on inside there. So this becomes log m squared plus log of n. And there was one last thing to do. What's the one last thing? Take the 2, put it up front. Absolutely. So the final answer is 2 log m plus log n. And if it feels weird, like to have log m, like it's too many letters running together, you are free to always put parentheses, if you like, on the single terms. Number 2 is just like number 1, mostly. After you change the radical to a power, is the radical on the p or the p and the q? Just the p, right? So how do you rewrite radical 3 as a power? 1/3. So this is really natural log of p to the 1/3 q. And now it's just like number 1, basically. You break it up into addition, and the 1/3 comes out in front of the p term. I can't with the p. I don't know. This is too much. So this is 1/3 natural log of that letter plus natural log of q. Agreed? I'm good. What's the difference on number 3? It's division. So when we break it up, we use which operation? Subtraction, right? So it becomes natural log of m squared minus natural log of n cubed. And then what am I going to do with the 2 and the 3? Bring it out front, right? That's our power property. Take it, bring it out front. So the first term is 2 natural log m, and the second term is 3 natural log of n. There's a person in the hall. They distracted. Bless you. Questions so far? I really like number 4. Log of blah, 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 blah. Do you want to start by rewriting the radical or separating it into 2 logs? What do you want to do first? I'll do whatever I hear first. That's what I'm going to do. Yes? You know, that's actually a logically correct answer to an OR question. So there's this whole branch of mathematics called logic. You can take an entire course on it in college. And if you ask this or, you said no. If you ask, it also can be in part of the philosophy or your law degree, because it's logical thinking, right? If you say, like, is it this or that, and it's one of them, and you answer yes, you have answered the question logically. It's not a very helpful answer, but it is logically correct to just say yes. But we're going to go back to it, and I'm going to rephrase it so that I force you to answer. Which thing do you want to do first? The radical or the separating? The separating? Okay. So that looks like this. Log radical 3 minus v minus log n cubed. And then we'll take care of the radical. There's one thing that, there's just too many people in the hall. What happened? Something bad happened? Did something bad happen in the hall? Should I just close the door? Are we distracted by the hall? I think it's too much. I can't. Teach with the door open. How many things are under this radical? 2. So when you rewrite with the power exponent, or fraction exponent is what I'm trying to say, You have to keep both of those things grouped together in parentheses. So these parentheses right here are required. Okay, 3 minus v. And then when you bring the 1/3 out front, you keep those parentheses there. You do not want to write this for your answer. Because what's going on there is you're, on that left log, you're only taking log of 3. The v is like its own term floating between the two logs. You're actually taking the log of this entire group, and so the parentheses are required to be correct. Any questions on the warm-up? No? You feel good? All right, let me give you your notes. We are using stuff from the last couple of days to solve equations that have multiple logs in them, right? So how many logs do you see in this equation? 2. Now we have solved log equations already by doing lasso, by putting the base, lassoing around, and then solving for x. We've done that. The problem here is, where do you start lassoing? There's 2 logs. Like if you put a 10 here and lassoed, you'd what? Pick this up as an exponent, and where would you end up here? Because there's that -1, and it wouldn't work. But if we can get the logs on one side and compress them into 1, then we can do lasso, all right? So that's our goal for today. But one thing we have to make sure about is whether any of our solutions end up being extraneous. So extraneous are extra wrong answers, kind of, okay? You get them by solving, but then you have to plug them back in and check it doesn't mess up your function somewhere. We've done this already this year when we solved rational equations. When there's an x in the denominator, you have to check that when you plug your answer back in, it doesn't make it 0 in the denominator, okay? For log equations, whatever you're taking the log of has to satisfy 2 things. What are those 2 things? You can't take log of what kind of numbers? I know you're saying something, I can't hear you. Negative. You can't take log of negative. And what else? 0. Okay. So whatever numbers you get, you have to plug it back in and make sure those things are avoided. So a solution is extraneous if you plug the value in and end up taking the log of a negative value or 0. Okay. So we have to check for those things. So here are the steps. I'm not going to read them to you. We're going to work them. We're going to go over them as we work a problem. And here's the first problem. So look at this problem. Read step 1, and I want you to decide in your head if step 1 is already done or if we have to do more work. And I don't want you to holler out your answer. I want everyone's brains to read and think for a moment. So you're reading step 1. Then you're looking at this problem and trying to figure out if step 1 is already done or not. All right, what did you come up with? What do you feel like? Is it? It's already done, right? So step 1 is all the logs on one side and the constant on the other. The constant is -2. Constant means there's no variable attached to it. All right, so that's good to go. So step 1 and done. That's done. Okay, read step 2 in your brain with your eyeballs, in your mind, in your thoughts, in your soul, and all of that. So it says combine the 2 logs using compression, multiplication, or division. What will we be using? Division. How do you know that? Because it's being subtracted. All right? So we will take those logs, compress them into 1 by making a fraction. That means that's what division is. How do I decide what goes in the numerator? Is it 145 or 4 minus 3x? 4 minus 3x. Whichever comes first when you're going from left to right, that goes in the numerator. and it equals -2. How many logs do we have now? 1. That's exactly what we wanted, because once you get it down to 1 log, you can do, guess what? The lasso, right? So that's our next step. So read step 3 to yourself. Guess what? You're gonna miss the whole problem. Is it very So step 3 is to write in your log and then do lasso. To do lasso, you have to start with the base. I don't see a base. It's 10. What would it say in order for the base to have been E? ln, right? Degenerous. But it doesn't say that. So we know it's base 10. See, y'all, sometimes y'all listen. All right. So you start with the base, and you go around. So I've got 10 to the what? -2 equals all this. Yes. All that blah, blah, blah stuff. So 10 to the -2 equals 4 minus 3x over 145. So then now your step here, now the rest of the problem is just solving. And this is just, the thing about the 2 notes from your, the 2 problems from your notes, all the problems on your homework, is once you get to this point where it's just solving, you have to use all your math skills, because they're all kind of different and they draw from different things. So here on this problem, there's a couple of ways you could get started. It just kind of depends on how you see the problem. Think about it for a minute, and just throw some ideas out how we could get started. What's something I could do? Yep, I could take care of that negative exponent, right? I could flip it, make the exponent positive. What else could I do? Multiply both sides by 145. I think that's pretty much the best two things. So let's take care of the negative exponent first, since that was the first idea we had. So 10 to the -2 rewrites as 1 over 10 to the +2. So that's something. Let's do the times 145 now. The 145s cancel on the right. And on the left, I have 145 over 10 squared. What is 10 squared? 100. So I'm just going to make that 100. I could also, at this step right here, cross multiply, with the butterfly thing? Cross multiplying is simply multiplying both sides by their denominators. So it's basically half of what we already did. What else can I do here? What can I do next? Subtract 4. So if I subtract 4 to both sides, how will I handle that with the fraction on the left? What do you recommend? Simplify the fraction, make it into a decimal, right? So subtracting 4 from both sides. So 145 over 100 is 1.5. 1.45. I just said one thing and wrote a completely different thing. And what is 1.45 minus 4? -2.55. And now what? There's only one thing left to do. You don't actually have any options here. Divide by -3. And you should get 0.85 equals x. Maybe. What do I mean by that, maybe? You have to check it. You have to check to see if it's an extraneous solution, okay? So we're going to take it back to the original equation. How many places do you see a log in the original equation? 2. Here and this one. Now this second one doesn't have an x, so I don't have to plug my solution in there to check it. It will always be 145, so it will always be positive and not negative. But I do need to plug it in there, the one that actually has an x. So I just substitute it for x. I do some math. And what am I checking for? That it's going to be still what? Positive and not 0, right? So 3 times 0.85 is 2 point something. 4 minus 2 point something is still positive. So 0.85 checks. That's good. If it hadn't checked out, it'd be extraneous, and we would just say it's no solution to the equation. All right, so let's do the next one. Next one's completely different, but it starts the same. The log stuff is the same process. So let's look at this one. I want you to take a second, look at it, read your step 1, and don't holler out what you think. Let everyone catch up. But I want you to decide if step 1 is done or we have more work to do. What do you feel like? Is step 1 done or we have more work to do? More work to do, right? So we need to get the logs on one side and the constant on the other. It does not matter which side you choose. Do you want the logs on the left or the right? Which one? Left. Okay. I heard other things, but that was like, I didn't know what they said. What you said. So I think that was the first clear thing I heard. So we're going to move logs to the left, okay? So this log needs to come over here by doing what to it? Adding it. One thing I want you to be clear about. Log is not a distributive property. This does not equal, this is bad. This does not equal log of x minus log of 9. Does not. Okay, that's bad. So when you're going to add it to both sides, it's this entire unit. You're keeping all of this together just like that. And when you add it to both sides. So don't do that bad stuff. So we moved our logs to the left. So what do I need to do with the constant? Move it to the right. What is the constant in this problem? The -1, right? So I'm going to add it to both sides. No, that's my son. I think he just saw me teaching. He's going to come back. So log of x plus log x minus 9 equals 1. All right. So that is step 1 done. Step 2 is to compress. Will I be compressing using multiplication or division? Thank you. Multiplication, indeed. So it's log of x times x minus 9 equals 1. Step 3 says to put your log in and lasso. You actually do have two options here. You could lasso right now and then distribute, or you could distribute first and then lasso. Which do you want to do, lasso first or distribute? Lasso? Okay. Let's lasso first. What's the base? Is it E or is it 10? 10. Okay. There's the base. 10 to the 1 equals x times x minus 9. Now this problem is completely different from the last one. It's not a fraction. There's, well, there will be in a minute, an x squared term. So we did step 3 was the last, so step 4 now is to solve. So when I distribute this x here, I've got 10 equals x squared minus 9x. So here's the thing. It's not like the last problem. It's not a fraction. There's no denominators to get rid of. There's an x squared term. So you might be thinking, I'm going to have to square root somewhere. And you might try moving stuff around to get that x squared by itself. You might move the 9x over. And then you have this. But then when you go to square root both sides, it doesn't really work on the left-hand side because of that 9x term. Okay? So you have to go back to the drawing board. You have to think about something else. And the reason why I went through all that was to let you know that that's okay. You don't have to know how to do the problem the first time you try something. If it doesn't work, you think about what else you know, and you try a different thing. Okay? That's like okay. You don't have to just like quit. So that didn't work. I thought I could square root, but it didn't work out for me. So then I look at the problem again, and I realize, okay, that 9x is throwing me off. What tools do we have? I was going to say skills or tools. It's going to come out stools. No. So, okay. X squared minus 9x, 10. What method can I do here? Factoring, right? I can factor. But before I can start with the AC thing and what multiplies to this and adds to that, what form does it need to be in? Not this form. I can't do it here. What do I have to do before I can begin? Yeah, very good. Thank you. I do. I have to subtract the 10 to both sides. I have to get it equal to 0. Come on, 7th period. It's like I've been at school all day already or something. So x squared minus 9x minus 10 equals 0. So our clues that we were going to have to factor and get it equal to 0 were two things. One, that there was a quadratic term, and that there was an x term. So that's what you're looking for to know if you have to factor. So then we do this. What multiplies to negative 10 adds to negative 9? I'm just going to tell you. Negative 10 and 1. Correct. If you're doing swing method, you divide by the a value, which doesn't change anything. Or if you do grouping, you're rewriting the middle term with the negative 10 and the 1. Either way, you get this. What do I do with those two things, those factors? Set them equal to 0 and solve. That's your zero product property. $10 and negative 1. Maybe. Perhaps. Possibly. What do I have to do with those? Plug them in, check that they don't make anything negative or 0. So we've got to check two things, 10 and negative 1. So we go all the way back to the beginning. There are two logs in this problem. If your solution fails one of the logs, you're done. You don't have to check the other one. So let's check which one of our solutions fails right here. The negative 1. Because if you plug negative 1 in there, the x is negative. You already know that's not going to work. Okay? You don't have to check it in this one. So we already going to throw out negative 1. But now let's check 10. If I put 10 here for x, is that okay? That's okay. 10 is positive. It's not 0. So if it passes the first one, you have to go check it on the second. It might fail the second one. What is 10 minus 9? 1. Is 1 positive? Is it 0? No. So it's good to go. So that means x equals 10 is our only answer. And negative 1 was what kind of solution? Extraneous. Okay. Miss Arnold was so kind as to create 2 additional practice problems before we do our homework. Would you like to do them? No, Aiden was like, no. Aiden said, Bob,